Hello students, welcome to this session where we are going to discuss the JEE Main Test 66 Physics section. Now I have solved it right now and I have regarded 6 questions to be tough, 6 were easy and 13 were medium, out of which I think the question number 4 there's some issue in the way they have solved, though I have ticked the answer but the question is not appropriate, options are not appropriate, question is fine. And this paper is actually a tougher one than the previous 2-3 tests that we were doing. It's not that easy, many people will find it really difficult. So again I say here, if you get 50 or 55 you are doing good enough, and if you are really good for advanced level then you should get 75 plus even in this paper, because the tough questions also have been the questions which you must have practiced. So let's see what's in the paper. So let's begin. An alpha nucleus of energy half mv square bombards on a heavy nuclear target of the charge Ze, then the distance of closest approach. So you can see this distance of closest approach thing is coming in many papers, both in NEET as well as the JEE Main. What we know, for distance of closest approach, the initial kinetic energy is converted into electrical potential energy, which is K. For the alpha particle charge is 2E, for nucleus it is Ze, upon what we have is R minimum, or the closest distance, like this, the potential energy. So what is R minimum? R minimum you can say is 2kZe square, and 2 and 2 will become 4 upon m. So what we have, m v square. So it is proportional to z square by v square, no. V square by z square, no. Z by v square, yes. So go for option C for this particular question. Next, an isolated particle of mass m is moving in the horizontal plane along the x-axis, okay, at a certain height above the ground. If suddenly explodes into two fragments, m by 4, 3m by 4, okay, and an instant later the smaller one is at 15 centimeter, the larger one will be, okay. So because it is horizontal plane, there is no acceleration at a certain height above the ground, it suddenly explodes into two fragments of masses. So what it means, basically it wants to say it was moving along the x-axis, okay. So let's say this is the horizontal plane xy. So it is moving along the x-axis at a certain height above the ground. So it is going like this. It is going like this. Okay. So the initial y coordinate is 0, and because of the explosion no external force acts. So still the CMY coordinate will remain 0. So what I can write? So m by 4 into plus 15 plus 3m by 4 into whatever be its y2 divided by total mass m will still be 0. So you can directly say 3y2 is equal to minus 15. So y2 is equal to minus 5 centimeter for sure. So go for option A, basic question on center of mass. Next, a boat is going with speed of 27 km per hour. You can convert it as, let's say, 15 meter per not 15 meter, sorry, it would be 27 into 5 by 18. So it would be, what you can have, this is 5 3 15 by 2 meter per second, 7.5 meter per second due east. An observer is situated at a 30 meters south of the line of travel, okay. So it is traveling due east, this is 30 meters south, okay. The angular velocity of the boat relative to the observer in the position shown is, so simply this is the observer, this is the velocity, so we need to take the component which is perpendicular to the line joining. So this angle is 45, so no issue. So the component perpendicular is, that would be again v by root 2 only, that is 15 by 2 root 2 you can write. So that would be equals to what I can say, omega into r. And what is r? This r, because this angle is 45, this angle will be 30, this is also 30, so this is 30 root 2. So what again I can directly say, omega would be v perpendicular by r. This is 15 upon 2 root 2, and r is what? 30 root 2. So in doing this is what it becomes, 15 upon 60 root 2, that becomes 2. So that becomes 1 by 8, that is 0.125 radian per second. Go for option A for this question. Next, an air-filled parallel plate capacitor has a capacitance C. The capacitor is connected through a resistor to a voltage source providing a constant potential difference V, okay. So it's a RC circuit. A dielectric plate with constant K is inserted into the capacitor, filling it completely. After the equilibrium is established, plate is quickly removed. Find the amount of heat generated in the resistor by the time the equilibrium is re-established, okay. So first of all, when it was fully charged by a dielectric, the charge is stored Q naught. I can write it as K times C into V. And in the new equilibrium, the charge stored would be C times V. So the charge that will pass through the battery initially it was positive plate, it was negative, it will still be positive negative, and it is losing the charge. That means battery, the charge will be, let's say, going in the reverse direction in the battery. So what we can say, the work done by the first of all, the amount of charge delta Q I can make out is K minus 1 times CV. So this much charge is passed. So what I can say, I have WB is equal to delta U plus H, you know this. So work done by battery here would be negative because the charge is going from positive to negative, and that would be equal to K minus 1 into CV square. Delta U is U final, which is half CV square minus half K C into V square plus the heat generated. So what we'll have as the heat generated, if I do, so what I can do, this is half K CV square minus half CV square minus K minus 1 CV square. So what we can do now, take the CV square common. This is K by 2 minus 1 by 2 minus K plus 1, that is what we are getting. So what we are getting, CV square by 2, if I take as common, this will become 1 minus K, that is what I can write for this particular. So I will go with this option. This is not available, so this is K minus 1, I can take it. That would be the answer for me. Ideally the solution given is not appropriate because they have only taken the change in the energy stored of the capacitance, they have not taken the battery's role. So therefore the way was wrong. Though the answer, looking by the options, I am going by B. I'll go for the option what I have written. I will go for the option B, or otherwise I would convert CV square by 2 1 minus. Now the next one, a metallic ring of radius r of negligible resistance as the resistance r connected across its diameter as shown. It is going with velocity v0 in a constant field b0 acting perpendicular to the plane of the paper in the inward direction. The current in the resistance is going to be. So what we will do here, so first of all, what we have here, this is basically, it is going, so we can assume whatever be the shape to be simply the endpoints connection is only mattering. So what I can see, let's say let be the 2 points M and N. So take this is the one loop, take this as the second loop. Okay, so these are the two loops because both are going. So the EMF induced, if I do that V cross B, if I do that V cross B, this N side will be positive in both the cases. So we will have this battery like this. Yes, V cross B like this. We'll have the two batteries like this. This is E, and this would be the R in between. So both batteries are in parallel, so the potential difference will be same. So I would be equal to E by R, and E is BVL. So B0 V0, and L will be the effective distance between the two, which is 2R divided by small r. So we'll go for which option? We'll go for option A, B V0 2R in by small r. That is it. We can go for 2 times. This is option A. Next one. A ball is projected at an angle of 30 degree above the horizontal from the top of a tower and strikes the ground in 5 seconds at an angle 45 with the horizontal, the speed for which it was projected. Okay, so it was projected at an angle 30 degree with the horizontal from the top of a tower like this. This is at 30 degrees, and okay, let me do this. Yeah, this one is 30 degrees. So let's say its speed is u. Now after 5 seconds it lands, and it lands at velocity 45. 45 is a very important hint. It means this Vx would be equal to Vy, and you know Vx is equal to Ux, so this V would be equal to root 2 times Ux. You can directly make out because it is 45 degree, so Vx and Vy are same. So, and plus the time taken to cover this is 5 seconds. Height is not given, no issues. So first of all, what I can write, so final velocity would be root 2 times Ux, and Ux is u cos 30. U cos 30 means this is cos 30 is root 3 by 2, so this becomes u root of 6 by 2 like this. Now if I, let's say, check for what I can say, if I check for y coordinate, what I can write, Vy would be minus Ux, that is minus u cos 30 minus, because we have taken this x and y like this, that would be equal to Uy is u sin 30 minus gt, g is 10 and t is, you are given 5 seconds. So from here what I can make out, minus u root 3 by 2 is equal to u by 2 minus 50. So from here what I can say, u by 2 1 plus root 3 is equal to 50. Okay, so you can do it from here only, that equation was not needed. U would be equal to 50 into 2 upon 1 plus root 3. So if I do that simplification, it will become root 3 minus 1 here, and it will be root 3 plus 1 into root 3 minus 1 would be 3 minus 1, that would be 2. So it is 50 into root 3 minus 1. So I'll go for option A. So simply you could have done from this equation only. Next one, the escape velocity for a planet from the surface is VE. The particle starts from rest at a large distance from the planet, reaches the planet only because of the gravitational attraction, passes through a smooth tunnel through its center. Its speed at the center of the planet will be okay. So first of all, because it has started from very large distance, so I can directly say, let's say this is the tunnel. When it reaches this point A, the velocity is going to be VE. The velocity at A is VE. Now you have to find the velocity at center. So from coming A to C, I know here the potential is gmm by r, and here the potential is minus 1.5 gmm by r. So this much gain magnitude gives us half mv square. Okay, now this is 0.5 times more, that is 3 by 2 times. So I can directly say half m vc square, directly I can say is equal to, let's say, 3 by 2 times half mv square. You can directly do that, no need in again applying that. You can directly simplify this. So this goes, vc would be root 3 by 2 times VE. So you can go for option C. That's not that tough if you are familiar with these concepts. Next, a body is cooling from a temperature 3T to T2T in 10 minutes. Okay, room temperature is T. Assuming Newton's law is applicable, the temperature of the body at the end of next 2 minutes. Okay, so what we can say, for the first 2 minutes the drop is the Newton's law. I can write minus dt by dt, so that is T by 10 minutes. It is equal to K times theta average. Theta average is 2.5 T here, 3T to 2T. So that is 2.5 T minus T. This is the first equation. Now let T final be the final temperature. Then for the next we have 2T to T final. So the drop would be 2T minus T final. Again time is 10 minutes. If I take the average value, this is 2T plus 2F plus TF by 2 minus T. This is the same equation I have applied. Now divide the both. What we'll have? T upon 2T minus T final, that would be equal to 1.5 T, and this would be, I can say, T cancelled. It basically becomes T final by 2. Okay, this goes. So T final by 2 is 1.5 into 2T minus T final. So this take it here, this comes out as what we will have, minus 1.525. This is 2T final is equal to 3T. So T final comes out as 3 by 2T. So go for option B, that is the most appropriate one. This is the answer for question number 8. Next, 1 mole of a perfect gas, that means ideal gas. You know that perfect gas means ideal gas. Initially at a pressure of this and temperature of this. Okay, this is the pressure, this is the temperature, respectively expands isothermally until its volume is doubled. Okay, so volume is doubled, that means this pressure, if it was P0, it will become P0 by 2 for sure, because volume is doubled. Now and then adiabatically until volume is again doubled. Okay, find the final pressure. So I have to apply the equation between 2 and 3. What I can apply, PV to the power gamma, so P0 by 2 into, let's say, 2V0 ki power gamma. So what we are given, the gas is not given, which gamma is given. Okay, 1.4. That would be equal to P final into final volume is 4V0 ki power 1.4. So what is P final? P final comes out as P0 by 2 into 1 upon 2 to the power 1.4. So it is P0 upon, you can say, 2 to the power 2.4. That is what you can write. Or you can say 0.5 to the power 2.4 into P0, and P0 is 10 to the power 5. So this is the A option I am seeing. This is coming out to be the right one. Now the 10th one. 4 identical uniform rods of 6 kg mass, each are welded from their ends to form a square and then welded to a uniform ring having a mass 4 kg. Okay, so ring is there, rod is there, 4 rods are there. Okay. The system then is allowed to roll down a rough incline of inclination 30 degree. The force of friction between the system and the plane is okay. So it is rolling down. First of all, let me calculate the moment of inertia about the center or the CM of the system. So what I can say, for this first rod, any rod, about this is ml square by 12, and what is L first of all. So what I can say, make out, let's say if I do this, because the diagonals are perpendicular, so this is r, and this is the side length. So what I can say, root 2r is equal to the length of the rod. So length of the rod is equal to root 2r. Directly you are making length is root 2r. So ICM for 4 times, let's say m of rod into length of rod. square by 12 plus if I shift it, this distance is I know is L by 2, so that is L square by 4 I can make out, plus for the what we had ring you know it is equal to mass of ring into radius of ring whole square, so that ICM would be 4 times 6 mm of rod. I should write 6 into L square, that is L would be what we have root 2 square is 2 by 12 plus 6 into again L square would be 2 by 4 plus what we have 4 into 1 square. Okay, so this comes out as 4 into 12 by 12 1 plus 6 into 2 by 4, that comes out as 3 plus we have 4. So what we have 4 4s are 16 plus 4 20 kg meter square. Now if I take this about IAOR, let's call this point P. So if I take this torque about IAOR, I can write it as I about the IAOR into alpha. So what I can find out alpha, torque would be, friction torque will be 0 because it would be acting upwards, you can make out, and its torque is 0, normal torque is 0, only the torque of mg sin theta acts. So mg sin theta into r divided by I about IAOR. So what we have mg sin theta is total mass here. Total means 6 4s are 24 plus 4, that is 28, to 228 g into 1 by 2 into r is 1, and upon IAOR. So I upon IAOR would be I about cm plus total mass, which is 28 into r square, which is equal to what we have, that is 1 square. So that is 20 plus 28, that is going to be 48. So this is 14g by 48, or I can write it as 7g by 24. Okay, so this is what we have written, 7g by 24. This is what we are getting. This is alpha. Now if I do about cm, so about cm only friction produces torque, so F into r should be equal to ICM into alpha. So F should be equal to ICM alpha plus alpha by r. You can go by the force method also if you wish, no issues. I'm going by this. So ICM is 20, alpha is 7g by 24, r is 1. So this is the friction that we are getting. This is what I'm getting. This is 5 times, this is 6 times, so it is 35 by g, 6 upwards, because you know, because about this IOR torque was this, so to produce this sense of torque, friction has to act up. So 35 by g, 35g by 6 upwards, that would be the answer you can do. Next one. So it's a good question. Next, elastic string has a, okay, after this is 10th, okay, this is 11th one. Yeah, elastic string has a force constant k, okay, and mass m. So it has a force constant k, let me check the marker, yeah, and mass m. The string hangs vertically and the block of unknown mass is attached. It is known that the mass of the block is much greater than that of string. The hanging block stretches the string to twice of its relaxed length. How long would it take for a low amplitude transverse wave to travel the length of the string stretched by the hanging block? Okay, so the block mass is very high, so basically what we have, the length has become L0 to 2L0. So the mu now would be m upon 2L0 in the new condition, and the tension we can take to be m plus mg, and because this m is small, I can write it to be, let's say, capital Mg. Okay, now, and what is this capital Mg? This capital Mg must be equal to k delta x, which is k L0. So this is how you can write this. Now the velocity of the wave, you know, is equal to root t by mu in the stress string. T, what you get, t is mg you can write it as what I can write it is k times L0, and mu is what you have it as m upon 2L0. okay, so you have this m upon 2L0. yes, we have written it right. So this is what we are getting now. So velocity, we will have L0 will come out, it would be 2k by m. Now the time would be distance upon speed, distance traveling would be 2L, so 2L by v, 2L0 by v, what you can write, so L0 goes, so what we have, 2L0 L0 root of m by 2k. So what you have now, you can write it as root 2m by k, root 2, because it will go 4m by 2k, root 2m by k, go by option A. Again, a very nicely designed question. If the de Broglie wavelength of an electron is equal to this times the wavelength of a photon of frequency this, then the speed of electron is, okay, de Broglie wavelength of electron, that is h upon mv, that is 10 to the power minus 3 times, and the wavelength means it would be c by nu. So what we have v as, h nu, let's say take it 10 to the power 3 there, that divided by m into c. So h is 6.63 into 10 to the power minus 34, nu is 6 in 10 ki power 14 into 10 to the power 3 divided by m. M is what you have, 9.1 into 10 to the power minus 31, and c is 3 into 10 to the power 8. So this is 2. Now first of all let me check the powers. So 14 and 3 17, 34, that is 10 to the power minus 17 above 6.63 into 2, so I can directly write it as let it write it only like this. Then this would be 9.1 and this would be 10 to the power 30 minus 23, so it becomes 10 to the power 6 into 2 into 6.63 upon 9.1. So what we'll have now, so if we do this, let me multiply it. 2 3s are 6, 2 6 are 12, 13.26 by 9.1, so it would be 1.4 something, so 1.45 into 10 to the power 6 meter per second is the answer. Now go for the next one. So 13th one, a load of 31.4 kg is suspended from a wire of this radius and density. Okay, calculate the change in temperature if 75% of the stored elastic potential energy is converted into heat. Okay, so it is suspended from a wire of radius and density this, so the change in energy. First of all, what is the stored energy? Stored energy, so here what we have, the energy stored converts into the heat energy. So first of all, what is the energy stored? That is the delta U elastic energy, which you call as half stress into strain into volume, we generally write. Now stress would be the force upon area. Strain I can write as stress upon, so strain is stress upon y, so this is F upon AY into the volume, and volume you can write it as mass upon the density because that is given to me. So this is mass upon density, that is what I can write. Okay, so now and this is the energy. Now 3/4 of this, that is 3 by 4 into 1 by 2 into F square m upon what I have A square y rho is equal to ms delta T, because that goes into raising the temperature. So what we have now, m and m get cancelled, so this change in temperature I can write it as 3 by 8 F square A square y rho by s. So this is the value. Now substitute it. F square is 31.4 into g, if I can write. So 31.4 into 31.4 into, let's say 9.8 into 9.8. I am taking 9.8 because the data is 9.8 in the downwards. Now pi r square is the area, so that would area square would be pi square. R square is 10 to the power minus 6, so that becomes 10 to the power minus 12. Now the Young's modulus is 9.8 into 10 to the power 10. The density is what we have, 9 into 10 to the power 3, and what is specific heat, we have 490. Okay, so now this 9.8 one get cancelled, this pi square, this would be 10 and 10, 31.4 you can make out. So what we have now, 3 into 100 into 9.8, okay, divided by 8 into 9 into 49. This is minus 12, this is minus 2, this will become plus 1 plus 2. Okay, so 10 14, yes, it is 10 to the power 2, so this goes cancel. So this is 9.83, I cancel, so 8 3s are 24 into 49. That is what we have got. And again this is 2 times, this is 10 times, so this would be 1 by 120. That is what I can write, 1 by 120 Kelvin. And what is 1 by 120? If I do it is 10 to the power minus 3, let's say 1000 upon 120 into 10 to the power minus 3 Kelvin. So 120, this is 100 by 12, that comes out as 8 point something, I think, yes, 8.33 into 10 to the power minus 3 Kelvin. So I'll go for option B. So again a slightly calculative one, but you can do this. Next one, your two identical ladders are arranged as shown in the figure. The mass of the block is small m and the mass of the each ladder is capital M. The length of each of the ladder is L. The system is in equilibrium. What is the magnitude of frictional force acting at A or B? Okay, so now this is a very good question. You might have come across this question before also. Let me draw the two legs like this. I am treating them both separately. This is A, this is B, and that P would be divided like. First of all, for equilibrium this tension is mg, and tension I distribute half and half to T by 2, or I should write mg by 2. Here also it is mg by 2. Let this pushes it upward and forward. Let's say this reaction force horizontal component is Fx and it would be Fy. From third law it would be Fx here and Fy here, so I can write this Fy. Both weight would be acting at the midpoints mg, and from the symmetry of the equation I can say the ground will exert the equal normal forces on A and B because both supports equally, and for balancing this friction would be like this at both the ends, and it would be again due to symmetry must be same equal to that Fx. So first of all, applying the force balances, one thing is F is equal to Fx, second thing is Fy plus n is equal to mg plus mg by 2. This is I have applied on the left one, and on the right one what I can write, what we have, n would be equal to fy plus mg by 2. So from these 2 and 3 it's pretty clear, for this to be possible this fy has to be 0, otherwise not possible. So fy is 0, that was we are also expecting, because they only push horizontally. Fy is 0. So now we are left with the equation. What we get, n is equal to m plus m by 2 g. So this is now my second equation. Let's say let remove them 2 and 3, let this be y, or let's call it 2 dash if you wish. Now do some torque balancing. Let's say about this point P over there, the torque of all these are equal. So balancing torque, what I get, mg into L by 2, and this distance I can write as L by 2 cos theta I can write. And friction torque is also in the same sense or opposite sense, it's also in the same sense. Okay, so mg L by 2 cos theta I had, plus friction, and friction component would be, the friction is going like this, so this length would be L sin theta I can make out. That should be equal to n into, that would be L cos theta, that you can say that should be balanced, because that is in opposite sense. So now what we get now, is this L goes. So what we have, mg by 2 cos theta plus f sin theta equals to n cos theta. So this is what I have, this equation as 3 dash I can write. Now we are searching for what value we are searching for, the value of small f. So putting the value of this n as this mg plus mg thing, so f sin theta would be equal to n cos theta, n was m plus m by 2 g, and cos theta minus I can have this mg by 2, again this is cos theta. So what I have now, m plus m by 2 g, cos upon sine is going to be cos upon sine, so it is going to be cot theta. So this is the value of friction that I am getting, and here is the option yes. So this is the option D for it. Now the 15th one, in a C configuration of transistor, the base current IE, it should be emitter current I suppose, IE is 2 microamperes, alpha is 0.9, then the value of IC is. So what we know, alpha is IC by IE, so IC would be IE times alpha. So it is 2 into 0.9, I can go for 1.8 microamperes. So it is option D, it should be emitter current, it is written wrongly here. A black body at temperature of 227 degrees Celsius radiates heat at the rate of 5 calorie per centimeter square per second. At a temperature of 727, the rate of heat radiated would be. So we know that H is proportional to T to the power 4 in absolute terms. This 227 means this is 500, 727 means this is 1000, so it is doubled, so it would be 16 times. So 16 and 5s are, that is 80. So again an easy one for you, directly you have to check the proportionalities. Next one, so this was your, next is 17th. If P represents radiation pressure, C represents the speed of light, Q represents radiation energy striking a unit area per second, then non-zero integers A, B, C are such that so is dimensionless. So we have to check dimensionless. So radiation pressure, whatever be the pressure you know is force upon area, which is mlt minus 2 upon L, that comes out as ml minus 1 T minus 2, that you are all aware of. Okay, now for the C represents the speed of light, because it is speed of light, it is LT minus 1 M0 you can write if you wish. And what we have, Q represents radiation energy, so it was Q, and this this was C, and now we have Q represents radiation energy striking a unit area per second, energy per unit area per second. So energy per second is power per unit area is intensity. So power upon intensity or energy, first of all ml2 T minus 2, you know, area is L square, per second means T, so what it comes out as mt minus 3. Now what you need P to the power A, Q to the power B, C to the power C to be dimensionless. So P to the power P, that means if I check for M, so M to the power A, Q to the power B, that is M to the power B, so plus B, and that C there's nothing, so M A plus B. Then what you have, L is minus A, and it's 0, and it would be plus C, and then T you have minus 2C, and not sorry minus 2C, it's minus 2A, sorry, it should be minus 2A, minus 3B, minus C, and this should be dimensionless. So first of all what we get, let me get it some lighter. Okay, A plus B is 0, so A plus B is 0, this is rejected, this is rejected. Next, A should be equal to C. So A should be equal to C. So what we are getting, A equal to C, so only option B is right. So you can check other things also, but the answer would be B. Next one. In a wide EIC bichromatic, that means that you have two wavelengths, 400 and 560 are used. Distance is 0.1, slit and screen is this. The minimum distance between two successive region of complete darkness. This is a very important question. This has been asked in JEE Advanced, this type of problems. First of all, what is the location of what you can say minimas? So minima, now let me check which minima will coincide. First of all, the minima of location, minima location that we have is 2n1 minus 1 into lambda t by 2d, that should be equals to 2n2 minus 1 lambda d by 2t. So if I check it, what I will get, this is getting cancelled. So lambda 1 lambda 2 I should write. So lambda 1 by lambda 2 would be equals to 2n2 minus 1 upon 2n1 minus 1. So what we will get, this would be 5 by 7. So what we have, we can directly say this is 2n2 minus 1. That means this is basically 2n2 minus 1 as fifth, that is n2 is equal to third. So third minima of what I can say of this lambda 2 coincides with, if I check, this is the fourth minima of lambda 1. Okay. Now the next will be possible when this 5 by 7, this will become 10 by 14, but 10 by 14 is not possible because this should be an odd number, so I'll reject that. Next would be 14 by 20, not 14, that is 15 by 21. So 15 by 21, if that ratio comes, so again then 15 plus 1, 16 by 2, that is the 8th minima of lambda 2 will coincide with what we can say is the, and that would be 21 plus 1, 22 by 2, that is the 11th minima of lambda 1. So the gap would be 7 fringe widths you can make out, because distance between two minima is a fringe width, so it is 7 lambda 1 d by d you can directly make out. So 7 into 400 into 10 to the power minus 9, d is what, 1, this is 10 to the power minus 4. Now what you will have, 10 to the power minus 7, and this is 10 to the power minus 3, this is 28, so we'll go for 28 mm. So it's a good question, you can do this in the way that I have told you now. The 19th one. The nucleus with mass number 220 initially at rest emits an alpha particle. If the Q is 5.5, then they calculate the kinetic energy. I just remember the kinetic energy. You just remember kinetic energy of alpha is approximately A minus 4 upon A by Q. That is approximately Q, slightly less. So 5.5 very close but slightly less. So I can directly go for 5.4. You can solve it also in these options. I don't want to solve because that's the way you remember these things. So I'm not solving, I'm directly writing it. You can solve it there. Next. Man holds a chain of mass m length L such that the lower end of the chain just touches the table. Okay. Now the man places half the length of the chain very slowly on the table while keeping the other half vertical. The work done by the man. That simply you can say that is equal to delta U. Now initially this was the chain. This is at the table. So taking this reference level to be 0, initially the Cm was here. So initial potential energy I can write it as mgl by 2. It would be mgl by 2. Now in the second picture, the half of the length is there and half is now on the table. So that half is 0 and that would be L by 4 and the mass above would be only m by 2. So the final energy would be m by 2 into g into L by 4, that is mgl by 8. So that W would be U final minus U initial. It comes out as minus 3 mgl by 8. That is what you can go for, option C. Next. The meter bridge wire AB shown in the adjoining figure is 100 cm long, AD is 30, okay. No deflection occurs in the galvanometer, that means it is balanced. So I can write this is 6 upon R would be AD upon dB. So AD is 30, so dB would be remaining 70. So R comes out as 6 into 7 by 3. This is 2, this comes out as 14 ohms, so go for option. You can write 14, not option, you have to put the value. So a small particle of mass 1 kg, charge 1 coulomb enters perpendicularly in a triangular region of uniform magnetic field of strength 2 Tesla as shown. What is the Vmax of the particle which it can enter so that it completes a half circle? Okay, let me draw this triangle like this. It won't be like this, okay. We'll need to, let's say, rotate it. I'll rotate it. Okay, it would be tough to rotate. Let me draw it. That would be the better option, I feel. So okay, so let's draw it. It would be better. So for the limiting case, I say, let's say it enters here and it goes like this. So this would be tangent. So let's say this distance is 2r, and angles, if I check 5, 4, 3, this would be 53, this would be 37. Now this would be center, so let's say this is perpendicular r. Now in the right triangle, this one, if I see this length is r, this is 4, so this complete length would be 4 minus r. So what I can write, sine 37 degree is equal to r upon 4 minus r. So 3 by 5 is r upon 4 minus r. So what you get, 12 minus 3r is equal to 5r. That comes out as r is 12 by 8, which is 3 by 2 meters. So because you have got the r, you know r is equal to mv by qb. So v comes out as qb r by m. Q is 1, b is 2, r is 3 by 2, m is 1. So it comes out as 3 meter. So the maximum possible radius that I can make out here will be, that the charge can make out is 3 meter. 3 meters. So the velocity is 3 meter per second, not 3 meter, it's 3 meter per second. So you have to fill only 3 because the unit is already mentioned. Next, a body is projected from the ground with some speed at some angle with the horizontal, taking the horizontal and vertical direction to be x and y. Okay, point of projection is origin. Calculate the minimum speed so that it can pass through a point whose coordinates are 30, 40 respectively. Okay, so this point lies on the trajectory. So what I can write, 40 is equal to x tan theta, that is 30 tan theta, minus g. Let me put g as 10. It is given, so put it. G 10 x square is 30 square upon 2 u square cos square theta. I should write it as 1 plus x square theta. You know 1 upon cos square, 1 plus 10 square theta, it is 6 square theta. So it is 1 plus 10 square theta. That would be the better way to write. Okay, you remember this, we always do these things. So you have to find the minimum speed. So for the minimum one, you need to, let's say, first of all, simplify this. What we are getting first of all, so this 2 becomes 5. So 40 is equal to 30 tan theta minus 30 square, you know, 900 into 5, that is 4500, minus 4500 10 square theta. I think this is, we have done somewhere this question, similar question. So let me do it again. So now what we have now, just multiplying this, what we will have, 40 u square is 30 tan theta into u square minus 4500 10 square theta. So if I take this as a quadratic in 10 square theta, so first of all, let's say what we are getting is, we are getting some things as common. What we are getting, this 0 0 0 0, it goes. Okay, so now what we are getting is this would be, let me check, x1 y 39 c square. Okay, so this is what we are getting now. So what let's say 10 square theta would be 450 10 square theta I've got, and minus what we will have, 3 tan theta into u square, and what we got, plus 4 u square plus 450 equals to 0. Now, so this is the value that we are getting for the tan theta. Now, for this to be real solution, d should be greater than or equal to 0. So what we'll have, 3 u square whole square should be greater than or equal to 4 into 450 into 4 u square plus 450. That is what you need to remember. So it is 9 u to the power 4 should be greater than or equal to what we get now, 1800. It's better we would have cancelled it. Okay, no issues. 1800 into 4 u square plus 450. So let me cancel it. This is 200. So u to the power 4 minus 800 u square minus what we'll have, 45 into 2, that is 90, and 000 should be greater than or equal to 0. So this should be greater than or equal to 0, and now you can factorize this thing, I suppose. So if you do this factorization, this factorization will leave you, or you make it a perfect square, u square minus, I can say, 400 whole square. So what you need, plus 16,000, so that is 9,000, so it will become minus 25,000. That should be greater than or equal to 0. So u minus 400 should be greater than or equal to, you can directly make it out, it is and 00 I make a, sorry, so this is 500, so it should be greater than or equal to 500. So u should be greater than or equal to 900, sorry, u square, not u square should be greater than or equals to 900. So u should be greater than or equal to 30 meter per second. So minimum speed is 30. Similar question we have done before, and it is not an easy one, it's a lengthy one. A tuning fork having a frequency 170 is vibrating just above a tube. Height of the tube is 110. Water is slowly poured into it. What is the minimum height of the water column required for resonance? So what you know for resonance, 2n plus 1 v by 4l should be equals to what we have, 170, and this L is the length of the air column. So we have to check the length of the water column. So minimum height of water means maximum length of air. So length of this air column, what we will have, 2n plus 1 v is what, 340 upon 4 into 170. So this is 2 times, so this is 2n plus 1 by 2. So minimum length L, air length possible is 1/2 meter. Then we have 3/2 meters. So because it is 110, it is not possible. So it is 1/2 meters. So the water length would be 60 for sure. So the water length would be 60 centimeter for sure in this particular case. Now the last one. For a certain lens, the magnification of an object when placed at a distance of 0.15 meter is twice of the magnification produced when it was at 0.2 meter. If in both the cases the real image is formed, then what is the focal length of the lens? Okay, so you have to compare the magnification in two cases. So you know the magnification you can write directly as whatever the formula we have. Let me derive it if you don't remember. We have, because it is lens, 1/v minus 1/u is equal to 1/f. So what we have now, so 1/v is 1/u plus 1/f, and magnification you define as v by u. So v, I can write it as uf upon u plus f divided by u. So here for the first case, it is what we got. Let me write it again. It comes out as f upon u plus f. Okay, so u cancelled, f upon u plus f. So the first case we have f upon u. U is what we have, that is minus 0.15. Remember the convention, that is twice of f upon minus 0.2 plus f. That is what we need to remember for this particular thing. So what we will have now, so this f and f goes, this is minus 0.2 plus f is equal to minus 0.3 plus 2f. So what we have, 0.1 is equal to f, so f is equal to 10 centimeter or 0.1 meter. So it's an easy one. Answer is going to be 10 centimeters. So this was today's paper. Hope you gained something by watching it. Please refer to this channel to your friends. Thanks for watching once again.